Welcome back to lecture 2 on Newton's laws. This one is just an extension of lecture 1. Now remember, if we look back in the first one, we just either just figured out the weight or the acceleration. Today, in this lecture, what we're doing, we're putting both together, because if you think about it, just to lift a box or an object off the ground, or even just to get you off the ground, you have to overcome your weight. So there's your mg. And if you want to jump high, you have to accelerate yourself, and there's your ma. So if you see something with a mass and we want to accelerate it upward, you would use something like this. So we would have a net force. And this F sub mg, now you may say F sub n or F sub w, but I like the mg because it tells you what I need. And same thing with the ma. So these are all forces. They're all newtons. And it says, what is the net force? So a net force is usually the best way to look at these, that I'm going to have to use something, a combination equation. So my mass is 20. Now to lift it just off the ground, I need to have my gravity in here. And then I just need to accelerate it. There's my acceleration, 1.5. And there it is. So forces are in newtons. So this next one is would be like a basketball person. Okay, they want to go accelerate up at 4.6 meters per second squared. So here's the net force. So there's a key phrase in this type of a problem, net force. So F sub net equals F sub mg plus F sub ma. Now I want to remind you, this is not F n e t equals F m g plus F m a. No way. You see, if you write this, chances are your teacher will count you wrong, at least on that part, because that's not what we have. Remember, there's no embellishments of our equations in the sciences. So F net, okay, my mass is 60. Okay, we got to get it off the ground. And then we have to accelerate it once we're off. And it's this right here. So my net force is equal to newtons. And let's kind of skip down. Now remember, tension is a force. So here's a little hint, net force. And if you've been fishing, you know you can't just, unless you have a very strong high test line, you can't horse your catch in. You've got to play with them. So you're probably thinking, okay, I got these, mg plus ma. Okay, I want the net force. Okay, there's a 10 Newton force. Okay, so what this is my mg. Okay, so we know that much is there. We can put it there. It's not necessarily the weight, but we're doing there. Plus, and we're going to accelerate it. Now you're probably thinking, why do we need to put a plus instead of a minus? Well, remember, if you're pulling one way and the fish is pulling the other way, that line's got to take care of both of y'all. So we need to add these things together. And since I'm wanting the net force, So my F net will be in newtons. Okay, now we could have something like this where we've got everything, and I just say, okay, look, we got the acceleration, but we're still using our net force, okay? Remember, if the rockets, they have to exert enough force to get them off the ground, and we've seen pictures in our history classes when they don't give enough thrust upward, that net force, and then it creates a little explosion, to say the least. So I got 10 times 10. Okay, I want the acceleration, so, just one unknown. And you should be able to calculate that. And then there's meters per second squared for our acceleration. You can see this one down here. I don't have the mass, but I would have the mass here and the mass here, and I can calculate that one real quick. So this concludes our lecture on net force and upward movement. Remember, if you do have any questions, don't hesitate to contact me.